We are going to start now lecture 3 of chapter 8 class 11th mathematics binomial theorem. So in this lecture we will study about the properties related to binomial coefficients. So first we have is this notation. We already know that when we are writing NCR, we can also represent it like CNR, or we can also represent in the form N and R. All these notations, these are similar. Next property that we have already studied, it is NCX is equal to NCY. If this thing is there, then either X is equal to Y, or we have seen that X plus Y is equal to N. We have these two results. Why? Because this thing we can also write in the form, we are saying that NCR is equal to NCN minus R. It means we can write it is NC N minus Y. Now N minus Y and X will be equal. So this implies us that X plus Y is equal to N. Next property that we have seen, it is NCR plus NCR minus 1, that is equal to N plus 1 CR. Next we have seen that NCR over NCR minus 1. These kind of results we have used in our previous lecture. The value we have, it is N minus R plus 1 over R. So you can remember this result as the standard result. Next, this result we have also used. It is NCR is equal to N by R, N minus 1 CR minus 1. So based upon this, the first question we have is find the number of dissimilar terms in the expansion of this. So if we look at this term over here, it is 1 minus 3x plus 3x square minus x cube. So this is basically 1 minus x cube. Now the power we have over here, it is the whole power we have over here, it is 33. So it is whole raised, this is 1 minus x whole cube and whole to the power 33. So we have it is 1 minus x raised to the power 99, and the number of terms in this expansion, that will be the value of n we have, it is 99. So the number of terms we will have, it is 100. So we are saying there are 100 dissimilar terms in this expansion. Next is let CR stands for NCR. This thing we know. We have to prove this result, that C0 plus C1 into C1 plus C2 so on up to these terms are given. So basically we are talking about NC0 plus NC1, and we know that the value of this term, it is N plus 1 C1. So if we solve all these terms, we will obtain this is equal to, we are saying if we substitute the value for corresponding terms, we will get it is N plus 1 C1 into N plus 1 C2 so on up to N plus 1 Cn. Now the answer we require, it is in the form of NC0 NC1. So to reduce these terms, we are using the result that we can write it is N plus 1 by 1 into NC0. Next term we can write it is N plus 1 by 2 into NC1 so on up to N plus 1 by N, and it is NCN minus 1. So we can write this as N plus 1 raised to the power, the number of terms we have over here, it is the total terms we have, it is N, divided by, it is 1 into 2 into 3 so on up to N. So it is N factorial, and over here we have the terms, it is C0, C1, C2 so on up to Cn minus 1. So this is the required, this result that we have to prove. Next is find the sum of the series. This series is given to us. Now if we look at these terms over here and we write the individual terms, we will have, we are talking about this value, it is sigma r is equal to 0 to n. The values we have, it is minus 1 raised to the power r. Then we have NCR. The next term we will have, it is 1 by 2 raised to the power r. Next is plus sigma r is equal to 0 to n minus 1 raised to the power r. We are talking about now the second term. So it is NCR, then 3 by 4 raised to the power r. Next is plus sigma r is equal to 0 to n minus 1 raised to the power r NCR, and we have it is 7 by 8 raised to the power n r. And likewise we are continuing in this way. Now if we talk about the expansion of 1 minus x raised to the power n, the answer we have, this is equal to sigma r is equal to 0 to n minus 1 raised to the power r NCR x raised to the power r. Now compare it with this first term. The answer we have, compare it with this first term, we are saying this is expansion for 1 minus 1 by 2 raised to the power n. Next term is plus 1 minus 3 by 4 raised to the power n. Next is plus 1 minus 7 by 8 raised to the power n, and so on up to m terms. Now this value is 1 by 2 raised to the power n plus 1 by 4 raised to the power n plus 1 by 8 raised to the power n, so on up to plus m terms. Now this is a finite GP with m terms. The first term of this GP, it is, we are saying a is equal to 1 by 2 raised to the power n. The common ratio r we have, it is 1 by 4 raised to the power n over 1 by 2 raised to the power n, that is equal to 1 by 2 raised to the power n. And the value of number of terms we have over here, it is m terms. So the sum of this GP, it is a into 1 minus 1 by 2 raised to the power n into m divided by 1 minus 1 by 2 raised to the power n. And on solving this, we will obtain it is 1 by 2 raised to the power n into 2 raised to the power m n minus 1 divided by 2 raised to the power mn into 2 raised to the power n minus 1 divided by 2 raised to the power n. So this 2 raised to the power n gets cancelled, and we are left with this answer. The answer we obtained is 2 raised to the power mn minus 1 over 2 raised to the power mn into 2 raised to the power n minus 1. Now the next we have is find the term independent of x in the expansion of this. So if we write the general term over here, we are saying TR plus 1, that will be equal to 9CR 3 by 2 x square raised to the power 9 minus r into minus 1 by 3 x raised to the power r. Now for the term independent of x means the power of x over here, if we calculate the total power of x, it is x into x raised to power 2 9 minus r. From here we will have it is minus r, and this part we are saying this should be equal to 0. So we obtain 18 is equal to 3r. So this implies us r is equal to 6. Now if we substitute r is equal to 6 in the coefficient of this term, the power of x is 0, so this term will become 1. So we will get it is 9c6 3 by 2 raised to the power 3, and next we will have it is minus 1 by 3 raised to the power 6. So this is equal to 9c3 into 3 into 3 into 3 divided by 2 into 2 into 2, and we have over here these 3, 1 by 3 raised to the power 6, these terms gets cancelled, we are left with 3 power over here. So we get it is 9c3 into 1 by 6 raised to the power 3, and when we solve this we will get the answer, it is 7 by 80. This is the answer we are getting in this case. This is the term independent of x. Next is how to find the terms free from radical or rational terms in the expansion of this kind. So the general term we have in this expansion, it is given by t of r plus 1, that is equal to NCR. The power we have over here, it is capital N, so we are writing capital NCR. A raised to the power 1 by p whole raised to the power n minus r, and b raised to the power 1 by q raised to the power r. So what we obtain from this is that t of r plus 1, that is equal to NCR a raised to the power n minus r by p and b raised to the power r by q. So we are interested in those values, we are talking about, look at these two values, we are interested in those values for which these terms, these are free from the radical sign. So first case we are saying, if the indices of a and b are positive, then free from radical sign terms there is equal to terms which are integer number of non-integral terms. We are talking about this value. So it is total number of terms minus number of integral terms. Next is if indices a and b both are non-positive integers, then the free term, they are rational terms minus the integral terms, and number of irrational terms we have, it is equal to total number of terms minus number of rational terms. So this will be more clear to you with the help of example that we are going to discuss now. So it is find the number of terms in the expansion this which are integers. So if we write the general term over here, we are talking about the value, it is 9 raised to the power 1 by 4 plus 8 raised to the power 1 by 6 whole raised to the power 500. We are saying the general term TR plus 1, we will have it is 500 CR. Then it is 9 raised to the power 1 by 4 raised to the power 500 minus R. And next it is 1 by 8. This is 8, not 1 by 8. It is 8 raised to the power 6. 1 by 6 raised to the power R. We can write this is equal to 500 CR. Then we are talking about this next value. It is 3 raised to the power. If we look at the power 3 over here, it will become 500 minus R by 2. And this value will become, this 8 we can write it is 2 to the power 3. So it will become 2 raised to the power R by 2. So we are writing this is equal to 500 CR 3 raised to the power 250 minus R by 2 and 2 raised to the power R by 2. Now we require the terms which are integers. So look at these values now. We are having R by 2 over here, R by 2 over here. And the value of R that we can have, it is 0 is less than equal to R is less than equal to 500. So if I substitute R is equal to 0, 2, 4, 6, 8, so on up to 500, for all these values R by 2 will be, we are talking about the value R by 2, that will be a integer. So how many such values of R are there? It is, we are having 500 by 2 plus 1, that is equal to 251 values of R, for which we will have the integer answer. The number of terms we are talking about, it is 251 terms are there, for which the terms will be integer terms. Next is find the sum of all rational terms in the expansion of this value. So in this case we are writing the general term, it is TR plus 1, that is equal to 15 CR 3 raised to the power 15 minus R by 5 and 2 raised to the power R by 3, and this is equal to 15 CR 3 raised to the power 3 minus R by 5 and 2 raised to the power R by 3. the values of r can be between 0 and 15. We are saying this will be an integer for 0, 5 and 15. This will be integer for 0, 3, then 6, then 9, 12 and 15. The common values of r we obtain, it is 0 and 15, for which both these powers will be integers. So we are interested in calculating the sum of rational terms. So we are talking about t of 0 plus 1, that is equal to t1, and t of 15 plus 1, that is equal to t of 16. So t of 1 we will have the value, it is 15c0, 3 raised to the power 3, 2 raised to the power 0, and it is 15c15, 3 raised to the power 0 and 2 raised to the power 5. We are substituting 15 over here, we will get this value. So in this case the answer is 27 and in this case the answer is 32. So the sum of both these terms, we have to calculate the sum of the rational terms, sum of both these terms, that will be 59. So this is the sum of both these terms. Next is find the number of irrational terms in the expansion of this. So if we write the general term over here, we are saying t of r plus 1, that will be 100 c r, then it is 5 raised to the power 100 minus r by 8 and 2 raised to the power r by 6. So both these 5 and 2, these are co-prime. So we are interested in calculating those values of r for which both these terms, these are rational. So we are saying that we require the values of r for which 100 minus r is a multiple of 8 and r is a multiple of 6, and it is and in between these two. Now if we look at the values for which r is a multiple of 6, it means we are interested in the values 6, 12, 18, so on and 96. Now out of these values, we want to find those values for which 100 minus r is a multiple of 8. We are saying, suppose these are the values of r. From this, if we calculate 100 minus r, the answers we have, it is 100. Then 100 minus r is 94. Then 100 minus r, this value we have, it is 12 over here. So it will be 88, then 82 and so on up to 4. Now out of these terms, we are interested in those terms which are multiple of 8. We want to find the number of irrational terms. We are saying we are trying to find those for which these terms, these are rational. So we have calculated the values of r for which this term is rational. Out of these, we are calculating the values of r for which the power of 5 is rational. Now we are saying out of these terms, if I try to find the terms, it will be the last value we will have over here, it is, if I write these terms in this way, we are saying it is 4, then 10, then 16 and then it is 22, so on up to 82, 88, 94 and 100. So we are interested in those values out of these values which are divisible by 8. So those values will be 16. Next value will be 40. Next value will be 64 and next value will be 88. So these are the 4 values of 100 minus r for which 100 minus r is divisible by 8. So the corresponding values of r we will have, corresponding to this 88, the value we will have, it is 12. For this 64 it is 36, for 40 it is 60 and for 16 it is 84. So these are the 4 values of r for which this term is rational term. The power of both 5 and 2, it is rational. So total number of terms, total terms in this expansion, it is 101, out of which we are saying the rational terms, the powers are integers, it is 4 terms are there. So we are left with 97 terms which are irrational terms. Now next we have is, if the second, third and fourth term in the expansion of x plus y raised to the power n are 240, 720 and 1080, then we have to find the value of x, y and n. So if we are writing the value of t2, that will be equal to nc1 x raised to the power n minus 1 y, and its value is given to be 240. When we are calculating t3, it is nc2 x raised to the power n minus 2 into y square, its value is given to be 720, and t4 it is nc3 into x raised to the power n minus 3 y raised to the power 3, its value is given to be 1080. Now if we divide first two equations, we will get nc2 x raised to the power n minus 2 y square divided by nc1 x raised to the power n minus 1 into y, that is equal to 720 by 240. And if we solve this, if we solve these values, we know that nc2 over nc1 we can write the value, and we simplify these terms, we will obtain the equation in the form y by x is equal to 6 by n minus 1. Similarly, if we divide the second and third equation, we are talking about if we divide the second and third equation, the result we will obtain, it is y by x is equal to 9 by 2 times n minus 1. Now if we equate both these values, we get 6 by n minus 1 is equal to 9 by 2 into n minus 2, and on solving this we will obtain n is equal to 5. So what we get from this is that y is equal to 3 by 2 times x. If we substitute this value in one of the previous equations, we will get y is equal to 3 by 2 times x. And from the equation 1 and 4, we will have 5c1 into x raised to the power 4 into y is 540. So this will give us the value of x is 2. On substituting this value over here, we will obtain the value of y is 3. So we will get x is equal to 2, y is equal to 3 and n is equal to 5. So these are the three required values. Next is to find the greatest term. We are saying that if tr and tr plus 1, these are the r and r plus 1th term in the expansion of x plus a raised to the power n, and we calculate the ratio of tr plus 1 over tr. We have shown these calculations over here. The answer we obtain, it is n minus r plus 1 over r into a by x. So suppose we are saying that the term tr plus 1, it is numerically the greatest term. If this term is the greatest term, then obviously we will have tr plus 1 is greater than equal to tr. So this thing will imply us that n minus r plus 1 over r into a by x should be greater than equal to 1. Or from this we will obtain that r is less than equal to n plus 1 divided by 1 plus mod of x by a. You cross multiply these terms on this side, you will obtain the answer in this form. So based upon this result, we can have two values. Either we are saying we will obtain r is less than equal to m, where m is any natural number, or we will obtain that r is less than equal to m plus f, where m is any natural number and f, it belongs to the interval 0 to 1. It is a fractional part we have. So in this case, when r is less than equal to m, we are saying there are two numerically greatest terms. One is the term tm and second is the term tm plus 1. We are saying r is less than equal to m. So these two terms are there which are numerically greatest. And if we have r is less than equal to m plus f, then the term tm plus 1 is the greatest term. Now the another method to solve this, it is, we are saying to find the numerically greatest term in this, we are writing a common from this, it is a raised to the power n into 1 plus x by a raised to the power n. Now if we calculate the value of m is equal to mod of x by a n plus 1 over mod of x by a plus 1. Now on calculating this value, we have two cases again. We are saying if m is an integer, then we have two greatest terms, tm and tm plus 1, both are the greatest term and both are equal to each other. And if m is not an integer, then t of m plus 1, this is the greatest integer function over here, this is the greatest term that we will have. So these things will be more clear to you with our next example. So first is find the numerically greatest term of the expansion this, where x is equal to 3 by 2. So if we calculate the value of tr plus 1 over tr, we will have it is 9 minus r plus 1 by r mod of 3x by 2. Now the value of x is given to be 3 by 2. So if we substitute this value over here, the answer we obtain it is 10 minus r by r into this value we will have it is 9 by 4. Now we are saying that suppose tr plus 1 over tr, it is greater than equal to 1. So this thing will imply us that 90 minus 9r by 4r is greater than equal to 1. This implies us 90 is greater than equal to 13r. So this implies us that r is less than equal to 90 by 13, that is equal to 6 whole 12 by 13. So what we obtain from this is that the maximum value of r is, the maximum value for r, we are saying r is always an integer, it is 6. So the greatest term corresponding to this we get it is t of 6 plus 1, that is equal to t of 7, and the answer we obtain it is 9c6 2 raised to the power 9 minus 6 into 3x raised to the power 6. Now substituting the value of x is equal to 3 by 2 in this equation and solving this value, we will obtain that 7 into 13 raised to the power 3 raised to the power 13 by 2. This is the largest term that we have. So this is one method, and another method we have seen it is, we are given 2 plus 3x raised to the power 9. We can write this is equal to 2 raised to the power 9 into 1 plus 3x by 2 raised to the power 9. Now if we calculate the value of m, it is n plus 1 into mod of 3x by 2 divided by mod of 3x by 2 plus 1. The value of x that we have to substitute over here, it is 3 by 2. So on substituting this value, we get it is 10 into 9 by 4 divided by 9 by 4 plus 1. Answer we obtain it is 6 whole 12 by 13, that is 90 by 13 we are getting, and we are saying that this is not an integer. So we are saying that t greatest integer of m plus 1, this will give us the largest term, and this is equal to t of 6 plus 1, that is equal to t7, and the value of t of 6 plus 1 we have already seen it is equal to 7 into 3 raised to the power 13 by 2. This is the value of t7, that is the 7th term we are saying. Next is find the numerically greatest term in the expansion of this, where x is equal to 1 by 5. So if we write this as 3 raised to the power 11 into 1 minus 5x by 3 raised to the power 11, we calculate the value of m is equal to 11 plus 1, that is n plus 1 into mod of minus 5x by 3 divided by mod of minus 5x by 3 plus 1. Now the value of x in this case it is given to be 1 by 5. So we will obtain it is 12 into, when we substitute 1 by 5 we get it is mod of 1 by 3 divided by mod of minus 1 by 3 plus 1. So it is equal to 12 into 1 by 3 into 1 by 3 plus 1. So it is equal to, this value will become 4, and this will give us answer as 3. This value will be 4 and this value will be 4 by 3. So answer we obtain it is 3. So this is the value of m that we have. So we are saying the value of m, it is an integer. We are saying m belongs to a natural number, integer, it is integer. So we have two values corresponding to which we have the greatest value, it is t3 and t4. Now if we calculate the value of t3, it is 11c2 3 raised to the power 9 minus 5x raised to the power 2. If we calculate t4, it is 11c3 3 raised to the power 8 into minus 5x raised to the power 3. Now if we substitute x is equal to 1 by 5 in both these equations and we calculate the value of both these terms, we will obtain the answer as, you can check by making these calculation, we will get the answer as 55 into 3 raised to the power 9, and this value is also 55 into 3 raised to the power 9. Both the answer, these are equal. So we are saying that the greatest terms, we are saying both t3 and t4, both these terms, these are the greatest terms in this case.